Today I'd like to look at integrating products of sine and cosine to different powers using trig identities to reduce it down. So talking about something like this, product of sine to the m, cosine to the n, where these powers are non-negative integers. And the reason I state it like that is they could be 0. So m and n could be numbers like 0, 1, 2, 3, 4, 5. The 0 is important because these techniques we're going to talk about work even if one of those guys isn't there. So it could just be sine to a power or just cosine to a power because one of those degrees might be 0. So it doesn't matter whether they're both present or not, the technique still works. Okay, so there's two approaches and it depends on the even or oddness of those numbers. If at least one of those is odd, we take one approach. But if they're both even, we take another approach. So first I'd like to look at the case where one of those is odd, at least. They could both be odd, that doesn't really matter. The key thing is that one of those degrees be odd. So let's go through this just by an example. So say we wanted the integral of, say, sine to the 5th times cosine to the 7th. Now I just mentioned that all that matters is at least one of them be odd. In this case I just made them both odd because I wanted to point out that when they're both odd, we're going to focus on the smaller one. That'll make our life a little bit easier if we focus on the smaller degree. So here's the logic of what we're going to do. The fact that it's got sine and cosine in it naturally makes us think that maybe a u sub would be appropriate, right? Because the derivative of sine is cosine, or derivative of cosine is negative sine. Now the problem is neither of those substitutions will work because we have more than just sine to the first, or more than just cosine to the first. So in either of those u subs, the du is simply sine or simply cosine, and we don't have it to the first degree. But that's going to be our goal. We're going to try and rewrite that so that one of those trig functions is now just first degree. And the one that we're going to do that to is the one that's the smaller odd degree. If there's only one odd, you have no choice. But if you have two of them, we're going to mess with the one of lesser degree. So the first step is to factor one of those off. So I'm going to take one of those signs off. That's sine to the 4th, cosine to the 7th, and I'm going to write that sign at the end. And the idea is that that is going to be part of my du. So if that's going to be part of my du, then the u that I'm shooting for is u being cosine. So what I would like is everything in here to be in terms of cosine except for that one sign I just factored off. So this is already in terms of cosine, so that's good. I want to rewrite sine to the 4th in terms of cosine. Well, because this was odd, when I take one off, it's now even, which is good, because anything of even degree could be written as sine squared to a power. In this case, squared. But if this had been 8, 10, 12, 20, any even number, we could write it as sine squared to some power. And then cosine to the 7th, sine x dx. And now, once you have sine squared, you can use your Pythagorean identity. Sine squared plus cosine squared is 1. Which means sine squared is 1 minus cosine squared. That's one of those identities we should know from trig. And now we have exactly what we want. Everything in this expression, all the trig functions have been switched to cosine except for that single sign there. And so we're ready for a u substitution. Remember, the goal was that was going to end up being part of our du, so the u was going to be cosine du negative sine x dx. So our integral becomes negative, we have a negative from that du, 1 minus u squared u to the 7th du. Now, what we're left with at this point is a polynomial. It's not in standard form. We're going to have to multiply it out and distribute that u to the 7th. But think about what makes that a lot of work. Right now, this can be pretty easy because it's just squared, so that's fairly easy. But the higher this degree had been, the higher this degree would be, which would follow through and mean a lot of algebra in foiling that all out. That's why at the very beginning when I said if they're both odd, manipulate the smaller one because that's going to lead to less algebra here. This 7 really doesn't affect the amount of work we have to do because all it does is get distributed through. So given 2 odd degrees, play around with that smaller one. Less algebra in the end. So I'm going to distribute that out. That's 1 minus 2u squared plus u to the 4th. Fairly straightforward because it's just foiling. If that's a bigger degree, you might want to use Pascal's triangle and use the binomial theorem to get that foiled out easy. If you don't remember that, you might want to review your Pascal's triangle and binomial theorem. Now I'm just distributing. And remember, when you distribute, you add powers. So it's 7 plus 2 and 7 plus 4, not 7 times 2 or 7 times 4. Common mistake. And now it's just a polynomial we can integrate. So I have minus 1/8 u to the 8th minus 2/10 or 1/5 u to the 10th plus 1/12 u to the 12th plus a constant. And then as always, when we do a u substitution, we always want to return back to the original variable. U in this case was cosine of x. So I'll finish off by switching back. And I'll go ahead and distribute the negative through. So I have negative 1/8 u was cosine minus a minus or plus a 5th cosine to the 10th and then minus 1/12 cosine to the 12th plus our constant of integration. So as long as one of those powers is odd, this technique will always work. You'll take this smaller odd, or if there's only one odd, then that one. Factor it off. Now, if it had been cosine, it would look very similar, except for we'd still be using the same identity. We would just be using cosine squared is 1 minus sine squared. It'll look very similar, except for with the u being sine in that case instead of cosine. So as long as one of those is odd, at least, this technique will work. If they're both odd, factor off from the smaller one, and you'll leave yourself with less algebra when you get to this step. Next time we'll look at what do you do if neither of them is odd? What if they're both even degree?